In the previous video, we've talked about light. What is electromagnetic radiation and its uses? In this video, I want to cover the wave-particle duality of light. What is wave-particle duality? Its photons behave like either wave or particle. It's shown really well in double-slit experiment. This experiment is first performed by Thomas Young to demonstrate the light behavior. So let's talk about the double-slit experiment. There is a source, quantum source. It can be light bulb or a laser, and there is two slits. They are close each other, and the size of the slit is small enough to compare with wavelength of light. And the other side, there is a wall to see the light behavior. Now we shoot the laser, then we think we will get two bands, like two slits. But it wasn't. The light behaves like a wave, so the light goes through two slits and they interface each other, and it gives constructive and destructive spot. So in the middle, they meet the most, so it gives brightest spot, and dark and bright, like that. Yeah. So I drew the approximate light intensity along the wall. It was interesting result. So this was like wave-like property. Then the researchers decided to put camera here to monitor one slit, and 50% of electrons were caught. So here assumption is 50% went through this slit by monitored by camera, and other 50% went through this slit. So after that, it made different result. It gives two light band as we first assumed. So this is like particle property. So let's talk about more for the wave property. When two waves travel and interface each other, it gives constructive interference and destructive interference. So for sine wave, path length difference, which is written in delta x here, is equal to n times wavelength, is constructive interference. And when delta x is equal to n plus half times wavelength, it gives destructive interference. So let's talk about this in double slit experiment. So there's two slit distance by d, and I will label those slits A and B. And in the middle, I will label as O, and straight to the wall is C. And I will pick any point and label as P. And this COP, I will label this angle as theta. So to know whether this point is constructive or destructive spot, we should compare the path length. So path length of from the first slit is AP, and second length is BP. So difference will be straight to the BP. I will label this spot as D. This BD will be delta X. So how can I express this delta X with theta, angle theta? So as I mentioned earlier, this distance D, these two wall and two slits are so far compared to this distance. So basically you can think these AP, OP, BP are parallel. So if I say this ABD as angle alpha, then these two are parallel, so these will be alpha too. But since it's so far, OP and BP can be predicted like parallel, so this will be alpha too. Then this theta is basically 90 degree minus alpha. So 90 degree minus alpha here will also be theta. So let's look at this triangle in detail. So there is A, B, D in theta angle, D distance, and here is delta X. This delta X is equal to D sine theta. So from here, if this is equal to n times wavelength, it will be constructive spot. If it's n plus half times wavelength, it will be destructive spot. Okay, so we've learned the wave-particle duality of light from double slit experiment. Well, from now on, we will think light as a wave. For the rest of the spectroscopy course, there are two reasons for this. First one is Bohr correspondence principle. Quantum mechanics reproduces classical physics in the limit of large quantum numbers. And second is the size of the molecules or atoms are much smaller than the wavelengths of light. So I try to draw the difference. So for example, in hydrogen atom, ionized energy is equal to 13.6 electron volt, which gives wavelength in 91 nanometer. We learned how to calculate this from last video. And the size of the hydrogen atom is 1.2 angstrom, which is equal to 0.12 nanometer. So there is a significant difference. So basically, we can neglect the size of the atom, which is the particle duality. So in this video, we've covered the wave-particle duality of light. And from now on, we will treat light as a wave. However, don't forget that light can also behave like a particle. Thank you.